So I would like to do number 7 in 3.1, which is about, is this quadratic or not? And that this I have is the square root of 5 plus the square root of 3 n to the 4th minus the square root of n to the 4th over 4.
Multiply everything by the power of 4, like 3 maybe? 3,
Just
2.
two. Just 2, and then multiply it all by 4.
Wait, why did you multiply
Put it all to the power of 2.
Wait, what are you doing to both sides? Why are you doing stuff to both sides? Oh, man.
Well, I mean, I haven't set it to 0 yet. But
The square root of 3 n to the 4th is n squared times the square root of 3. And
Is that the other thing you were trying to do? Powers?
yes.
Okay, so if you think about the square root as a 1/2 power, right? You guys remember that trick? So you could think about this as the square root of, oops, that's supposed to be a 5. Square root of 5 plus, let's see, the square root of 3 times n to the 4th to the 1/2 power.
Okay.
You guys all with me on that? I did something weird, right? Anybody confused on what I did, or are we okay?
I know what you did. The way you wrote it on my booth. But I know what
Okay, so I
I
had the square root of a times b, right? And so I thought about that as the square root of a times the square root of b. And then I rewrote this one as a 1/2 power because that thing already had a power on it. And so I'm going to hit it with a rule. All right, what about your other guy here? You know the square root of n to the 4th?
Yeah, it's n squared.
N squared. And on the bottom you got a 2. Rad. Okay, so if I just said I know the square root of n to the 4th, I should have done this one right away.
Yeah, exactly.
So what's the square root of n to the 4th again?
N squared.
N squared.
Yeah.
Okay.
So look, we have squared.
There's squareds. That's
There's two
cool.
squares. You should combine like terms.
Okay. So I got the square root of 5.
You can't just add it to the square root of 3. You just have to put plus square root of 3, right? Yeah.
How many n squareds you got here?
2. One.
No.
Dang. You have 1.5.
No.
You have half.
Okay. I'm buying that's a half an x squared, an n squared. So it's minus a half n
Oh,
squared.
so you
But
have
whatever.
you have a half n squared.
So kind of you have a half n squared here. How many n squareds you got over here?
Oh, 3 squared. 3. Oh, I thought that was a plus for not times. Yeah, yeah. Square root of 3 times 3.
Yeah, you got the square root of 3 n squareds here.
Yeah.
Right? Like, you got the square root of 3 apples, and then Susie takes half of one of your apples.
Yeah.
So you have
How many apples left?
the square root of 3 minus a half. And then what are you talking about?
N squared.
N squareds. Right? It's as simple as knowing that if you had the square root of 3 apples and somebody took half of one of them, that you would be confused.
Half of one of the n squared.
So your branch just factored n squared.
Yeah, another thought I could use, right, is I really just factored an n squared out of those terms.
Yeah.
And so, what am I left with here?
Vertex form.
Straight up.
Kinda, not really.
Yeah, this is actually vertex form. If I thought about vertex form a little bit, this guy's your k, right? That's your vertical shift.
Right.
What's this whole business here?
That would be h. The negative 3 is the a. Is the negative 3?
Yeah, that's a.
Oh.
Right? Because that's all a number that's being multiplied by n squared.
Oh, right.
So that thing's all a, and what's your,
H.
like here you're thinking
H is 0.
h is 0. So with that, that's kind of fundamentally ridiculous. Yeah, it's fun. Good time. So what was the answer? Is this a quadratic?
Yes.
Yeah.
Yes, it is a quadratic.
Yeah.
Please note, there is a thing you have to be careful of.
These. And thank you.
No. Please note, the square root of x squared which you would like to think of as being x, right?
No, absolutely not.
Is not in fact x.
It's plus or minus.
X to the
It's
half.
not plus or minus x.
X to the half.
Uh,
What?
It's x squared to the 1/2, right?
Oh, that's.
Which your little exponent rules would say like, oh yeah, just slash it out. It's x to the first, right? But why is it not x?
Because that doesn't exist.
Nah.
If it's negative?
If you plug a negative number into this thing,
It's negative x.
square it, you get a positive number,
The
right?
absolute value of x.
Yeah, and then you square root it, you get back to the positive side.
Yeah.
Right.
So it doesn't show you the.
This thing is actually the absolute value of x. Right, so you got to be just a touch careful with these, because if I had right here an n squared instead of an n to the 4th, this would not be quadratic, because it would be a quadratic and an absolute value.
Okay.
You guys see that? So there's a very similar problem where this is not, where this does not work quite the same way.
Okay.
Cool?
Okay.
Questions?
Yeah, isn't it any even exponent causes it to be an actual value for some real square root?
Yeah. Yeah, so if you had x to some even power, and you took a square root of this, yeah, this would be an absolute value of x to the n.
Yep.
Because the even power is always going to spit out a positive result. And then when you feed it through the square root, you get back to where you started, except positive. Hence the absolute value. Cool? In these cases, right, I really have the absolute value of n squared here.
Yeah.
But the absolute value of n squared and n squared are the same thing.
Oh, I see.
Because n squared is always positive, right?
Yeah.
You guys cool with us? That is a subtle distinction.